So I'll try to cover what we are doing with WorkLight and PhoneGap and how it's bringing the mobile applications to the enterprises. In terms of agenda, I'll quickly try to set a context for WorkLight and how it's using the PhoneGap framework as a part of the architecture, and then we'll dive right into the demo. In the demo, I'll try to cover a couple of application management features, and then also features related to enterprise connectivity, and then backend integration. So this is a very, very high-level overview of the WorkLight architecture. What WorkLight is a mobile application platform, and it provides the enterprise-grade software solutions to deliver applications to the organizations and to build applications using hybrid, native, or HTML5 based technologies. So at the high level, in the top left, there is the Studio, which is the integrated IDE for your cross-platform application development. As you go down, the second component, the WorkLight server, now this is basically the middleware that sits between the backend infrastructure and the mobile applications that are running across a range of devices and different platforms. And using the middleware capabilities, it provides a range of very advanced functionalities. Some of them are listed here. I'm not going to go through them, but one of them is basically a unified push framework that I think in the earlier talk when Bryce came, he was asking about how we could solve the issues with the push notifications, which are very different across different platforms. There's also a device runtime layer. This is actually packaged along with the app. So you have this when you have the applications installed and running on the devices. And this does a lot of runtime functionalities. One of it is the cross-platform compatibility layer. And it also integrates, if you see here, it integrates with the WorkLight server, which is the middleware to provide runtime components and encrypted storage and range of other functions. There's also WorkLight console, which is basically to manage the applications once they are deployed and running across different devices. Now, PhoneGap is embedded as a part of WorkLight solution. And if you look at the client architecture here, then you can see that PhoneGap is one of the core components of the client architecture that we provide. In addition to additional APIs provided, so here, for example, there are APIs provided so that you have uniform way of accessing the UI components across different devices, such as dialog boxes, tab bars, etc. But you can see that as a JS to native bridge, we do use PhoneGap so that the apps which are either hybrid or mobile web apps, they have access to the device-specific features and functionalities. And what this does is that WorkLight is enabling PhoneGap and bringing it to the enterprise customers, and as a way of building the hybrid apps using web-based components and technologies. And they can do this now in a cost-effective manner using these solutions, combining PhoneGap with all the other APIs that are provided. And also it helps them reaching a range of different devices and platforms, which wasn't possible before. So that's the client architecture. I'm not going into the detail, but after the talk, if anyone wants to, I can get into as much detail as you would like. So now that we have developed the application which are cross-platform compatible by using web-based components and resources, what happens beyond the cross-platform application development? Because an app is not a standalone entity, they need to integrate with the authentication framework, which is running in the backend. They need to deal with different kinds of web resources and sources of the data, which are already deployed in the backend, and they might be in not so friendly data formats. So how do you deal with the integration of different sources which are running in the backend? You also need to have some functionalities and a very robust solution around security. And actually, you do need to worry about scalability in the real world, because if you think about a B2C app, a business-to-consumer app, you can very quickly scale from hundreds of users to tens of thousands of users. So scalability is not a marketing paradigm when you're talking about B2C apps or even B2E apps in certain use cases. So that's one set of issues that the enterprises are dealing with today as we go to them and propose them solutions for building mobile web apps. The other solution is when you have your apps running across these different platforms and different devices, how do you actually manage the applications? How do you do some basic things like how do you do version control? How would you go about directly updating some of the components of your application, right? and how do you do certain other things. For example, what kind of analytics do you have in place so that you can get the raw data across the platform and then try to make sense of it, try to actually understand how your users are using the apps, how they are using the alerts, how they are using the notifications, so that you can build much better applications. So I think with that high-level context, basically WorkLight along with PhoneGap, it kind of complements PhoneGap and then provides very advanced functionalities around the infrastructure so that you are delivering true enterprise applications for your organizations. So with that context, I'm going to quickly switch to the demo for all the demo happy people here. So here I have, this is the WorkLight server. It is basically a Tomcat servlet, and it's configured locally on this laptop. But in a real production environment, you'll be either configuring it as a hosted environment, or you would have it as a part of your backend infrastructure. So that's the server which is running here. I have the Android emulator, and I have a WorkLight starter app which is running here, and it basically takes the RSS feeds from the backend, and that's what you're seeing in real time. Now, I'm going to go ahead and make some changes to the CSS file for the starter app. I picked pink for no apparent reason. I'm going to save it and issue a build for this application so that it builds for the Android platform in this case. Now, the feature that I'm trying to show you is basically direct update, and the advantage here is that you'd be able to directly update the web resources and components of your application directly from the server. So of course, the advantage is that in case of time-sensitive issues, you are not waiting on the App Store approval process. You are not waiting for the changes to be uploaded to the marketplace before the changes take effect. Okay, now I have the application built here successfully, as you can see. I'm gonna restart the app. So in the sense of direct update, one is the time sensitivity factor. Second is that your users are more or less guaranteed that they always have the most updated version of your application, because this is not like they need to do an explicit download to pick up the components. This will be done implicitly by the runtime layer, which is provided by the platform and the middleware itself. So you are guaranteed more like the apps running in the browser, but this is for your hybrid apps. You are ensured that you have most up-to-date version which your users are interacting against. So here I have a dialog box and alert saying that an update is available for the application. I'm going to go ahead and click on the update. So right now it's downloading the components, the CSS file that we changed from the server, from the middleware, onto the emulator. And one important thing to note here is that all these components are zipped. So when you make changes to a bunch of files or something, then in terms of performance, you do gain an advantage because the files are zipped as opposed to you getting them chunk by chunk, one file at a time. So here you can see there's the updated app, and the fonts have changed to pink for the feeds. So that's the direct update feature. Now there are some restrictions, some licensing restrictions for iOS, but it depends a lot on what kind of enterprise license you have in place or what kind of changes you have made. So if it's a functional change, probably you may not be able to do this effectively, only for iOS. But if it's a minor patch or bug fixes, then you would be able to use this feature. For Android, of course, out of the box, you can make the changes and the features will be effective. One point to note here is that this is also very important from security perspective, because if you do have applications running in different platforms across different devices and you come up against a security flaw, then you do want to release the bug fixes and the patches for that in a very timely manner, in matter of hours, as opposed to waiting for the changes to be uploaded in the App Store or somewhere else, even in your internal data store distributions for that matter. So from the security perspective, this is one of the features that enterprises have really asked us to build for them. The second feature that I want to show here quickly in the demo is, again, an application management feature. And here, what I'm going to do is I'm going to go ahead and disable the same WorkLight starter app that you saw in the emulator. So I'm going to disable this app, And I'm going to bring up the emulator and restart the same starter app again. That's not from the emulator. So here, this is a pretty whiny app. Well, actually not, it's going to the pub. But the point is that the application has been disabled. Now, where exactly is this useful is in a couple of scenarios. One is that you have all these applications deployed across different platforms, different devices. What if you want to retire a particular version 1.0? So this gives you a fairly granular control in sense of disabling the applications which are already running on different devices. And secondly, again, think about it from the security perspective. So you found a flaw, you found an issue. Now this gives you, even if it's a big hammer approach, it gives you an option to disable the application and solve the problem at this point. So those are a couple of use cases, but there are many more in which you would need to disable the applications as one of the application management features. Now, in the future version, we are going to make it more granular. So right now, it's basically the application version and the platform, as you saw. But it can be tied to the OS version and also to the device ID so that it becomes much more micro level in terms of the application that you want to disable. So that's the second feature. I'm going to go switch to the PowerPoint slide. So the third one is related to enterprise connectivity. And this is basically when the enterprises want to deliver alerts, notifications from their backend to different applications running on different devices, again, across different platforms. A big problem is how do you do it in a unified manner? Because each of the platform vendors here, so the APN servers by Apple, the C2DM by Google, they do provide the push-based registration and services, but as you can imagine, each of them exposes very different APIs to do that. At the same time, the push services which are provided by these servers are very different, very unique. And on top of that, there are operational complexities which are associated with dealing with each of these platform-specific servers. So how do you take away all the complexity away from the application developer so that they're not really learning how the APN or C2DM works, but they are focusing on delivering the notifications and handling the notifications. So for that, there is a unified push framework which is provided. So here, you could implement adapters to get the notifications from the backend, and they could be either polling-based adapters or message-based adapters, depending on what you choose to do. You have a unified push API. This is on the server side. So what happens is that this API will take care of all the complexities underneath and send these notifications, which it receives from the adapters, back to each of the platform-specific push mediator, again, which is Apple's push server or Google's push server. It also maintains, remember this is the middleware piece, so it does have its own internal database. And what it does is it maintains a user preference mapping. So there is a mapping between the user, the devices, and the different notifications that the user might have subscribed to on this device. And it also maintains a notification state database so that it keeps track of what are the previous notifications that have been delivered to the user. So what you gain from here is that you'll be able to dynamically determine by looking at this database what is the right notification to send to which particular device, because all the bookkeeping is done here internally. Yeah.
When you say user, do you really mean a device or do you mean a user? Users have multiple devices.
No. So here the mapping is between the user, all the devices that is tied to the user, and then the notifications that they might have subscribed to on each of the device. But it is possible for you to do that either way. You could do it based on the user ID, or you could do it based on the device as well. So here, the platform-specific dispatchers are implemented as well. And if you don't really want to use the push-based servers, then you can configure it to use a SMS dispatcher to do the same thing. So from the iOS dispatcher, it will invoke the right APIs and send it to the push mediators. So all this is the server-side component. You also have client-side APIs, which are, again, unified APIs for two purposes. One is to register for these push services, and second is to handle the notifications as they come. Now, for the registration part, this is actually implemented as a PhoneGap plugin, and we are going to contribute this in the coming days as a PhoneGap plugin for all the push-based registration services. There is administrative console to manage the notifications, to deal with the event sources and some other bookkeeping information that gives you much more insight into how the notifications are being used. Now, how does it work under the hood? So I'm going to go through this quickly. So this is the application code, and it will bring up the information that the subscriptions that the user wants to register to. That information will be given to the notification SDK, which is provided by the platform. And the notification SDK will invoke the notification API, which will send this information back to the platform OS. Sorry, I was hitting the wrong key. And then the OS sends it back to the push mediator, which is again APN or C2DM. At the same time, the notification API is also going to send this information back to the middleware so that it can update the subscription database that you see here. And if needed, this information could be passed back to the data source so it can keep track of the information that a user has subscribed to a new notification and do what it needs to do. Now, this completes the registration piece. On the other side, when the notifications arrive, the first thing is the subscription database gets updated, and that information is sent to the dispatcher. Again, it's the platform-specific dispatcher, as you saw, for each of the platform, and that will be sent back to the push mediator, back to the OS. Now, if it's Apple, the notifications would be handled, in case of iOS, it will be handled directly in the device. In case of Android, it will be forwarded again to the notification API, and then it will be handled in the application. Now, all these notifications are encrypted, and to do the encryption, we get the application certificate from the push mediator as the initial handshake, which the middleware establishes with each of these servers. So here are the APIs on the client side to both to subscribe to the push-based registration services and then to unsubscribe. And you can see these are pretty straightforward APIs where you provide your adapter and the event source. This is an example of the event source. So this is actually a polling adapter, as you can see. So you have specified the interval in which you would poll the backend for fetching the notifications. And at the same time, the handler is this function called produce notifications. Now here is a quick flow of how it works. So basically, worklight.server.invoke HTTP will get the data from the backend. Once it has the data, and this was to answer your question, this is how the user subscription object is maintained. So once it gets the notification data, it can extract the user ID from the subscription database. And then it will determine who should be notified, not only based on the user information, but also based on the notification callback, the state that it had maintained in the database. Now it's going to update the subscription database here. In this case, it's a very simple update. It's just incrementing the count, but you could change it to do something else as well. And then the last thing left is to actually notify the device itself. So here you can see you can customize many things here. So you can deliver the notifications as SMS or as a badge or as an alert box, and you can configure your custom payload. This is the snapshot of how it looks. So here it's basically delivering the coupons from the platform. So in summary, though I went over this very quickly, the point is that the ability to send notifications from the backend, it's fairly complex because of different servers that you need to deal with. And using the unified push framework, you are able to take away all the complexities. And as an application developer, as an enterprise provider, all you are focusing on is what are the notifications to be delivered, and then how do you handle them on the client side. Now, the next feature is yeah. So it could be both ways. You could go for a hosted solution where you could host it in a cloud, or you could also work with Worklight to provide. But mostly we have seen that the paranoia around security is so high that you want this to be part of your DMZ zone or part of your backend infrastructure. And it's a Tomcat servlet, so there's nothing really fancy going on here, but you could also configure it for WebSphere or something else. And the last thing here is basically around the integration. So this helps you with basically simplifying the data integration. So you don't really need to flatten the hierarchical data that you have received from your backend. So what happens is that server will automatically convert any hierarchical data that it receives into the JSON format or some other standard format for the client applications to consume. And I'm going to show you a quick example here because somebody is looking at the clock quite frequently. Okay. So here I'm going to, these are basically the debugging capabilities. You can see that you can invoke the backend services and quickly test them in the platform. So these are helping you with the server-side debugging capabilities. And here, as you see, there is a path rss.xml. And this is how, when you saw the Worklight application, it was getting this, okay, I don't have it here, but it was getting these feeds from the RSS backend. Now I'm going to run this, and you can see there is a XSL transformation in the code here. So I'm going to issue a run. And what will happen is that it will convert the XML data, the hierarchical data, implicitly into JSON format. And if you have, so here is the raw XML data in this section. And this is the XSL, which you can customize as you wish. And it will apply the XSL transformation and then generate the JSON object for you. So here it is in the last section. So this basically, from the client perspective, it simplifies you and makes the data retrieval very easy, especially in the cases where you have different formats to deal with in the backend. So it will do a data mashup, and then it will automatically do a JSON translation because that algorithm is built into the middleware. So with that, I'm gonna wrap up, and these are some of the resources which you can use to play with the platform. Nothing is disabled, so you can download it and hack the heck out of it and see how it might or might not meet your enterprise needs. Any more questions? I'll be more than happy to answer them. I'm right there in the back, and thanks a lot.